Hello, guys. Welcome back to Math Zone African Motives. In this case, we are going to consider a revision that is from the Limpopo province, which is for our test one or the term one test or the term one revision that we are going to have. So we were given, this was written on 18 March 2025. So, meaning to say, if you are from Limpopo province, yeah, those are the dates that you also must expect for 2026 exams around those dates. All right. Anyways, we are given a 2 hours paper, which was actually out of 100 marks. All right, 2 hours. So we are going to quickly go through our question paper. Make sure that you go through your instructions and information. That was this question paper consists of 7 questions. All right, answer all the questions. All right, that is, make sure that you read everything, guys, and also the answers to be given to 2 decimal places unless stated otherwise. All right, so that is what we have got. Number one, question one. 1.1, we are given to solve for x. Solve for x. That is, we can have an equation to be solved, or we can have an inequality to be solved. Those are the questions that we can have under solving. All right. So as we can see, the first one, which is 1.11, that was an equation given that the left-hand side is equal to the right-hand side, which is 0. That's an equation. So how can we attempt that? There are 2 brackets that we are given. So we can simply take advantage of that. X plus 3, 2 minus x. Remember the 0 product, a times b to be equal to 0. It's either a is supposed to be equal to 0 or b must be equal to 0. So that is, we are going to consider that concept, that is either x plus 3 is supposed to be equal to what? To 0. Or we can have the 2 minus x also being equal to 0. So we can solve for x. From the first equation, simply subtract 3 both sides so that we can remain with x. So that means x is equal to what? Minus 3. 0 minus 3. That was going to give us a minus 3. There we have got a minus x. So we can get rid of that x, put it to the other side, all right? We can simply take it to the other side so that it becomes a positive. So that's 2 is equal to what? X. 0 plus x by simply adding x both sides. So meaning to say x as a positive is equal to what? To 2. Or if you wanted to remain with that x on the right hand side, on the left hand side, as it is 2 minus x is equal to 0 like this, you can take the 2 to the other side or simply subtract the 2. So meaning to say we were going to have minus x equal to what? 0 minus 2, that's minus 2. So to obtain x, we're going to divide by what? A negative 1 to get rid of the negative that we are given there. All right, so that was it, meaning to say x will be equal to what? A positive 2. The same thing that we are given there. So that is how we could have also attempted in case you wanted to maintain the x as it is on the left hand side. All right, so that is it, guys. X is gonna be equal to 2, or x is what? Minus 3. So those are the 2 solutions that you were going to expect. All right, let's consider 1.12. That is an inequality that you're given, a quadratic inequality. Given a quadratic inequality, remember the steps. We must obtain the critical values first. So meaning to say, from the given inequality, that is x squared minus 2x minus 15 is greater than or equal to 0. Let us first consider the critical values, which we can have by first factorizing the given quadratic. All right, let's first factorize this. X squared minus 2x minus 15. All right, the coefficient there is 1, so you can simply have x and x here to give us what? X squared. So considering the factors of what? The constant negative 15, which must add up to negative 2. So which products or factors of what? Negative 15. But these two numbers, when added together, we must obtain what? Negative 2. So that's 5 and 3. There's something here, negative 5, or we can have negative 3. Okay. There are so many negative 15 and 1, 15 and negative 1. But where we have got a 2, that is between these two. All right. So we need to obtain a negative 2. From these factors that we have, if we add, we must obtain what? A negative 2. So you're going to see that was happening on minus 5 and what? 3. If we add these two, that is going to give us what? A negative 2. Minus 5 plus 3 is negative 2. So those are the two. Negative 5 here and a positive what? A positive 3. So we are going to use those ones for now to obtain the critical values. So take note, the factorization part is just for us to have the two brackets which we are going to use now to obtain the critical values. It is just like solving an equation, just like this state, where you were given two brackets equal to 0. So that is the condition you are going to take whenever you are to obtain what? The critical values. So you take as this bracket and this bracket to be equal to 0 as an equation. You take it as an equation. All right. So meaning to say either one bracket will be equal to 0. So minus 5 to the other side was going to give us a positive 5. The positive 3 to the other side is going to be what? A negative 3. So those are the solutions to the equation, not the inequality, but to the what? To the given equation. Using these solutions or our critical values, let us now determine the exact solution to the inequality. As we are given that this whole function that we are given here, it is greater than 0, greater than or equal to 0. What are the conditions when you are given an algebraic graph and you are given that it is greater than or equal to 0, considering above the x-axis, the solutions which are found above the x-axis? All right. So in our case, the shape, as we have got a positive a, is greater than 0, so meaning to say we're going to have it concave up like this. All right, so it's gonna be facing up, something like this. All right, so this is our x-axis, and as we are to consider from our f of x, like I said, greater than or equal to 0, that's above what? The x-axis. So meaning to say our solutions taken above the x-axis, we're gonna have these ones on the left-hand side and these ones on the right-hand side from the given critical values that we have, the negative 3 and what? The positive 5. Just like that. So therefore, what are we going to have? This side of our solution, these values, they are less than negative 3. But at the same time, as we have got our question, there is an equal to. So you must also put that one on your answer. Or we can have another set of values from 5 going up, 6, 7, 8, and so on. So those values, they are greater than 5. But since we have an equal to, we are going to also consider it on our solution. So meaning to say, these are the x values. Anything that is less than or equal to negative 3 is considered. Any number that is greater than or equal to 5 is considered as part of our solution if you are to input that into this inequality, you are going to have values that are greater than or equal to 0. You're going to have positive values. Or you can use anything, guys, the number line concept. You can use also the table method, all those methods that you had in your grade 11 to find the exact solutions at the end. All right, without wasting your time, guys, 1.2, given this, all right, for any value of x, which is a real number, for which value or values of x will this part be undefined? All right, so the key statement it is what? Undefined. This is the key statement. For the given expression or term that we have, as it is a single fraction, you can just consider it as a single term. For it to be undefined, what are the conditions? We simply refer back to a fraction as we are given a fraction. What are the conditions that a over b will be undefined? It is when the denominator is equal to 0. A over 0 like this is undefined. This cannot be simplified. Cannot be simplified. We can have a fraction, guys, 0 over b like this. That is going to give us a 0. 0 over 1, 0 over 2, whatever that you want. But not to have in the denominator 2 over 0. This does not exist. Remember our grade 11. So we take advantage of that to say, since the denominator is 0, this is what we have numerically as a number. Once you have a 0 there, the given fraction is undefined. So what is our denominator in the given fraction? We have it, the square root of what? Of x plus 5. So thus, from the undefined concept, it follows that the square root of x plus 5, which represents the denominator, must be what? Exactly equal to 0. That fraction is now undefined. Once this whole part here of the square, once you put a 0 here to say the whole part of this is a 0 like this one, it is undefined. For whatever value of x, x plus 3 over 0, whether it is going to be negative 5, is going to be positive, whatever that you have, but as long the denominator is equal to 0, that fraction is what? Undefined. All right, just like that. So let us solve for x from that statement of being what? Undefined. We can solve for x, get rid of the square root, simply square both sides of your equation. So that was going to neutralize our square root. You remain with x plus 5, which is equal to 0 squared. That's a 0 there. So to obtain x, we can get rid of the 5. Simply subtract that both sides of your equation. That means we've got 0 minus 5, which is what? Negative 5. So for this value of x, when it is equal to negative 5, it means our denominator will be equal to 0. And thus our fraction becomes undefined. So let's put that like negative 5 here, negative 5. You're going to see that that was going to give us negative 5 plus 3, which is negative 2 over what? Negative 5 plus negative plus this 5, that's going to give us a 0. So we've got square root of 0, which is what? A 0. So the moment we have this as a 0 like this, it is what? Undefined. We cannot simplify that part. All right. So whatever that you're going to have minus, it was 5. All right. It's only that. Let me put it this way. Minus 5 plus 3, everything over the square root of minus 5 plus a 5 as it is. You see that undefined again, which is the same thing that we are having here. This cannot be simplified. All right. So the x value is supposed to be equal to what? minus 5. So that is how we can simply attempt these typical questions. All right. Then on the other part of our question, it was now to solve for x. Solve for x. All right. That's 1.22. Given this whole equation that we are given, let us solve for x. It is x plus 3, everything over the square root of what? X plus 5. And that is equal to 1. How can we solve for x? All right, we have got a fraction. Actually, they are fractions because we can have this one as 1 over 1. That is a fraction. So let's get rid of that fraction. Simply cross multiply. So 1 is going to multiply this. 1 is going to multiply. So guys, as we can see, 1 times whatever that you are given there simply remains as it is. So that is, we're going to have x plus 3 equal to 1 times this. It is going to also remain as it is, the square root of what? X plus 5. Since we are to solve for x, and this is an equation that we have, we are now back to our equations under sets from our grade 11. How do we get rid of the square root? We square both sides. So we're going to square, get rid of this. So that was going to give us x plus 5. All right. On the left-hand side, we have got the x plus 3 raised to the power of 2a plus b squared. Remember, this is equal to a squared plus 2ab plus what? B squared. So that's going to give us x squared plus x times 3 times 2 is going to give us what? 6x plus 3 squared, which is what? Which is 9. That's 2ab, 2 times a times b. Like this, it's going to give us 6x. That is what we have. And as we can see, guys, the highest power is 2, a quadratic equation. So we must have the format now, ax squared plus what? Bx plus c is equal to 0. So to have that, take this to the left-hand side. So that's, you're going to have x squared, 6x minus x. The moment it crosses the equal sign, it changes the sign. So that was going to give us positive 5x. The 5 to the other side also changes the sign. So it's 9 minus 5, which is what? Which is 4. And that's equal to 0. Now that we have got this as the standard form of our quadratic equation, we can use the factorization to solve, or we can try the quadratic formula. Now it is in your hands. Using factorization, let us try, because yeah, it is easier, as we have got the coefficient of x squared being 1. So you're going to just have x and x here. Then we consider now the factors of what? Positive 4. But when we add these, we must obtain what? A positive 5. So positive 4, its factors 4 and 1. If you multiply this, you're going to get a 4. 2 and 2. Those, as we can see, it's a positive. Yes, we can have those negative 4 and negative 1, negative 2, but do not worry about this, because as we can see, guys, we have a positive. So there is no way we can add a negative and a negative to obtain a positive. Like one is negative, another one is negative, and you add. There's no way. But we can have a positive if both are positive, as it is. So which one? That is 4 and 1. If we add here, it is going to give us a 5. So that is 4 here and a 1. Okay, so that's equal to 0. Solving this, we are back to what we had on question 1.11. 2 brackets equal to 0. So it simply means one of these 2 must be equal to 0. So that's x will be equal to what? All right. We're going to need also to check this. 4 to the other side is going to give us a negative 4. Positive 1 to the other side was going to give us a negative 1. As we have got these solutions, remember we are dealing or working with an equation that is under sets. Like I said, from our grade 11. So we must test for these two solutions that we have. Are we going to obtain exactly what is on the right hand side? It's either you can test from the second one or you can test from the first one. That one is, it is up to you. So we can simply use the first one as it is. It is a said as it is. It is a said. That's a said. So let's try for minus 4. When x is minus 4, we're going to put it into our calculator as it is. So let's have a fraction minus 4, that is our x value, plus 3, everything over the square root of what? X is what? Minus 4. So that's minus 4 plus what? Plus 5. So that was going to give us a negative 1. A negative 1. Is it a negative 1 that we have here? No, it's a positive 1. But here we are obtaining a negative. You must have exactly what we are given here. Positive 1. So meaning to say this does not give us exactly what we have on the right hand side as we saw here. For the value of x being what? Negative 4. What about when our x is minus 1? Let us simply put here in place of negative 4, put negative 1. We go up, we do the same, put negative 1. If we simplify, we are going to obtain exactly a positive 1. Exactly. This is exactly what you are given on the right hand side. A positive 1. So this is the exact solution that we are going to need. So therefore, our x is equal to what? Negative 1. When it is a negative 4, there is no solution there. We are not having an exact part as we are given on the right hand side. It does not correspond. So always, whenever you see the square root, this square root, as said, do test your values. You must test your values. All right. So that was it on question 1. 11 marks, everything on question 1. Let us move on to question 2, which was under our number patterns. Given the following geometric series, all right, they told us exactly what we are working with, a geometric series. Then we are given on 2.11, determine the value of what? Of R, the common ratio, in terms of x. Our answer must be in terms of x. All right, so it is easier, guys. We can simply determine that one, as we've got our terms t1, 2, 3, and what? And 4. So we do understand that to have R, that's t2 over t1, it can be t3 over t2, which is taken from tn over t of n minus 1. So if it is 2, this is going to be 2 minus 1, which is 1. So that is it, guys. So what are you going to have? T2 is 12, positive 12, over what? T1, which is 24 over x. So that is 24 over x. And as we can see, guys, this is a division. We are simply dividing 12 to what? 24 over x. This is what it means. So remember that this is same as over 1. We can simply introduce multiplication and invert the second fraction, meaning to say x on top, 24 in the denominator. All right, 12 into 12, that is 1 into 24, 2. From the numerator denominator concept, multiplying the numerators together, 1 times x, that is x. 1 times 2, the denominators, that is 2. So this is our R in terms of x. 2.12, if x is 4, determine the sum of the series to 10 terms. If, that is the major statement, if x is what? Is 4. If, work from there, take as it is, then determine the sum to 10 terms. All right. This is a geometry, guys, which we do understand that the sum of terms is given from this formula, from the formula sheet, or you can use the other one, which it is up to you. Using the formula that we have from the formula sheet, all right, let us consider that. We are given that the sum to any terms that you're given will be taken from a into r to the exponent of n minus 1 over what? Over r minus 1, which we are going to need them numerically, not in terms of x. That is why you are given the statement if x is what? Is 4. They do not want you to obtain it in terms of x like before. If it was like that, they were not going to give us this statement that x is what? Is 4. They were just going to say determine the sum of the series to 10 terms in terms of x, just like before. So meaning to say all these are needed are needed numerically. What am I referring to? The a, the r, and what? N. So n we have, remember they say to n terms, to 10 terms, So n is already there. N is equal to 10. What about a? We do not have that one numerically. A is equal to T1, which is given in terms of x. So let us start with that one. 24 over x, meaning to say that is 24 over what? Our x is 4. 24 over 4, that was going to give us what? That was going to give us 6. Then our r there as the constant or common ratio is there in terms of x. So we are simply going to substitute the x that we are given as what? As 4. So 4 over 2 is what? Is 2. So there we simply substituted where there is x with 4. Where there is x with what? With 4. To have numerical values. With these values, we can determine the sum to 10 terms. So that's S10 is equal to what? A, the first term, is 6. So that is going to be into our r there, which is what? Which is 2 to the exponent of n. Remember, 10 terms minus 1. Everything over what? R minus 1, which is 2 minus 1. So that is it. With your calculator, you can simplify this, all right? Just have a fraction. 6 open bracket 2 to the exponent of 10. All right, then subtract 1, close the bracket. Then in the denominator, we're going to have 2 minus 1. All right, so that is it, 6,138. So that was going to give us 6,138, just like that. They need you to obtain the numerical value, from what you're given. All right, so that was it, 2.12 for 3 marks. 2.2, we are given the sum of the first n terms. We are not given the terms, we are given the sum. The sum, that is the major case. So meaning to say whatever that you're given here is representing what? The sum of terms, and that is of what? An arithmetic series. All right, so lucky enough they told us it's an arithmetic. So meaning to say it was taken from this sum. Remember, this is your arithmetic. They simplified it until they obtained that part that we are given here as what? Minus n squared plus 8n. But anyways, let's see. 2.21, sorry. Calculate the sum of the first 15 terms. Already we are dealing with the sum of terms. So simply use that. as Sn is given as negative n squared plus 8n. So if it is to 15 terms, it is still under the sum. Use as it is. 15 in place of n, substitute what? 15. So that's minus 15 squared plus 8 times 15 in place of what? N. Where we have got n, we substitute that 15. So using your calculator, when I have minus, then you open the bracket. The minus is outside of the bracket. Take note. The minus is outside of the bracket. So it's minus. Then we gonna have, all right, then we're gonna have 15 squared like this, all right? 15 squared plus 8 times what? Times 15 like this. Exactly what you're given. So that was going to give us negative 105. All right. So that's negative 105. This is what we are going to have. Just like that. We have got the sum. Take note. The second part, calculate the value of T15. That's a term. The 15th term. 2.22. So in order for us to have T15, remember, from the sum of terms, we can obtain the nth term from Sn minus 1. So if it is T15, it is going to be taken from n is 15. So this is also 15 as 15 minus what? As 14. 15 minus 1, which is 14. So if we check properly, we have got S15. We calculated it. This is the one that we got as negative 105. We do not have S14, the sum to the first 14 terms. But since there's a formula for sum of terms, use it to determine S14, just like how you determined S15. So it follows that S14 is what? Minus n squared, which is 14 squared, plus 8n, that is 8 times what? 14. So that's it. Using our calculators, let us have 14 this time here. And 14 here. That was going to give us negative what? 84. So we have got these now. We've got these two, S14. This is our S14, negative 84. So take the two, combine them. That is going to give us T15. S15, the sum to the first 15 terms, negative 105, minus, what are we subtracting? The sum of the first 14 terms, which is negative what? 84. So this was going to give us T15 at the end. By simplifying this, minus 105 minus negative what? 84. So that's negative what? 21. So this was going to give us negative 21 at the end. So we've got T15. You could have actually simplified the Tn from the formula Sn minus Sn minus 1. You could have just used it as it is from there. Simplify it in terms of n. After that, you just substitute your T15. It's another way of simplifying it, all right? It's another way of simplifying it. Let me just do it for the sake of revision. What I'm simply trying to say is that, all right, if there's some, all right, we're going to do that one later on. Do not worry. In case we are going to need this, all right, no problem. In case, just remember these values because I need to erase this part. What I'm saying, guys, is that we could have determined that Tn first, as it is taken from Sn minus Sn minus 1. Sn is there, we are given that statement already. That is our Sn minus n squared plus what? 8n. Minus n squared plus 8n. So what are we going to subtract? We are going to subtract Sn minus 1, meaning to say in place of n, this time we are going to have what? N minus 1. Wherever there was n, we are going to have n minus 1. So it's going to be like this, minus n squared. Our n is what? N minus 1. So it's going to be n minus 1 squared. So it's going to need us to have this proper bracket here. All right, so let us have it this way. Okay, plus 8n. So we're going to have plus 8. Our n is now n minus 1. So this is it. So expanding the brackets, simplifying this, you're going to have the nth term in terms of what? In terms of n. So that's negative n squared. All right, so the first part is just going to remain as it is, negative n squared plus 8n minus, let us expand the brackets here. All right, remember the a minus b concept, a minus b squared. It's a squared minus 2ab plus what? B squared. So meaning to say it was going to be negative n squared, that's a squared, minus 2ab, so it's going to be 2n plus 1. But we're going to multiply by the negative, this one outside of the bracket. So it's negative times n squared, which is negative n squared. Negative times negative, positive 2n. Negative times positive, negative 1. So this is what you're going to have from that part. Then 8 expands the other bracket. 8 times n, 8n times negative 1, that's negative 8. So this is it. We are going to collect the like terms inside of this bracket. All right, so meaning to say that was going to be minus n squared plus 8n minus. Collecting the like terms, the n squared is just going to remain as it is, minus n squared. But there is a 2n here and 8n. Those are like terms, n and n. So 2 plus 8, that was going to give us what? 10. So we got 10n. Then the constants, minus 1 and minus 9. Minus 1, and minus 8. So minus 1 minus 8 is what? Minus 9. So that is it. Now that we've got this, we're going to expand the bracket with a negative. So it's negative n squared plus 8n. Expanding by the negative, negative times negative, that's going to be positive. All right. Negative times this positive, that is going to give us negative. Then we have got negative times negative, which is positive. So that's positive 9. Collecting the like terms, we have got the minus n squared, and there's a positive n squared. So as you can see, those two are going to cancel, guys. This is minus 1 plus 1. So this is going to cancel. 8n and minus 10n. So 8 minus 10, that's minus 2. All right, then on the constants is just 9 as it is. So this is your Tn. You could have determined it first from this formula. Then you can determine whatever that you're being asked about, what? This Tn, the value of T15. So it follows that to find or to obtain T15, as we have got the nth term, so therefore T15 is equal to what? In place of n, simply put 15. So that's minus 2 times n, which is 15 plus what? Plus 9. So this is what you're going to have. Simplify. Minus 2 into what? Into 15 plus 9. So this is negative what? 21. Exactly the same answer that we obtained in our previous calculation. Only that there is a lot of calculation. It is necessary for you to actually do this when the Tn is needed. Somehow there is a part or a question where that is to be used later on. So you can check your questions. Is there a part where you're going to need that one? If not, guys, then leave it. All right. But if you understand it, guys, it's exam. Use what you understand. Use what you understand. So that is it, guys. So that is from our TN. Another way that we could have used. All right. Anyways, let us consider 2.23. If the first term is given, all right, all right, these ones, guys, in case you're gonna need them, just to remember these values, all right, because I'm just gonna erase and use this part. So 2.23, we are given that if the first term of the series is what? Is 7. The first term, that is our T1, which represents A, and that is equal to 7. Which term of the series will we have? We will have a value of which term of the series? What will be the value of n if Tn is what? Negative 169. All right. So now let me use the one that is from the second method of answering. For those now who used or who obtained Tn in terms of n, this was your advantage now. If let's say you've got your Tn, this is your Tn, remember, from that arithmetic part that we simplified, then this is what we have. So for those who had this part, it was your advantage. So I'm going to start with these ones. Then I'm going to answer the rest of you guys. All right. So let's say you have your Tn like this. It was an advantage because already you have from the previous statement, we've got our Tn, which is equal to what? Minus 2n plus 9. So you can take advantage of that one. Since the question here is asking about the and what is going, which term of the series will have a value that is equal to negative 169. And that is exactly the Tn that we have. In this case, in this method, there is no need of you using, this one is not even needed. These two, they are enough, as you have got your Tn and Tn. So you can equate these two. So therefore, minus 2n plus 19, plus 9, sorry, must be equal to negative 169. Since we need n, solve for n. All right, get rid of this positive 9, subtract 9. So that was going to cancel. Minus 2n is equal to minus 169 and negative 169. Then we subtract 9 there. It was going to give us negative 178. Negative 178. So to have the value of n, simply divide by what? Negative 2 by negative 2. So that's our n. Well, this was going to cancel. 178 divided by 2, that is what? 89. So n is equal to what? 89. So it is T89, which equals what? Which equals to negative 169. That is what it means. So you see the advantage part when you had worked it from this side. It was going to be straightforward for the next question. For the next question. But let's say you used the first concept where you calculated T15 from S15 and S14, meaning to say for you guys, you won't be having this Tn unless you are to find it. You won't be having it. So what can you do now? All right, so let's find another way. It simply means there was another way. So this is another way that we could have answered. We do not have Tn is not there. We do not want to talk about that Tn. All right. So remember they gave us the first term, and we do understand that this is what? An arithmetic series. All right. We do understand that. It's an arithmetic. We are given the first term. So what we can do is to find the Tn. Since we have got Tn and we've got the first term, remember Tn for an arithmetic is given as what? A plus n minus 1 times d. So that's for our arithmetic. So we're going to have Tn is equal to A plus n minus 1 times d, which we do not have. Some of the, here we do not have. We have got A, we are told the first term is 7, but we do not have d, the constant difference of an arithmetic series. So what can we do? Since we already know the type of the series that we are dealing with, we can work with the terms that are following each other as d is equal to Tn minus 1. As long you can have two terms that are following each other. Like here you calculated T15. So if you want, you can calculate T14. Then find the difference. You can find whatever that you want. T16, find the difference. It is still going to give you the constant difference from T15. Or you can use T1 as you are given that A is equal to what? To 7. That's T1. So we can find T2 since D is going to be Tn minus T of n minus 1. So T2 minus T1. So the question now is, where are we going to obtain T2 as we have got this T1? Remember from our sum formula. So this one I'm going to remove it. We are done with this part, guys. All right. Remember from our sum formula, we need what? To determine T1. And Tn is taken as Sn minus S of n minus 1. So that's T2 is equal to what? S2, T2 is going to be S2 minus S1. Of which, what we must be very, very careful about is that when you are given Sn formula, it follows that S1 and T1 is the same. S1, you don't calculate to say n is 1. No, S1 represents T1. So it means we have got that from what? From our T1. That part, I explained it on a separate class. Remember that? When we talked about this formula, Sn, sum of terms, determining terms from it. So S1 is already there, meaning to say that's our 7. What we do not have is what? S2. So we must determine S2. All right. So S2 from our sum formula, S2 is equal to what? S2 is simply equal to, remember, Sn is minus n squared plus 8n. So you're simply going to substitute. S2, n is 2. Minus, in place of n, we put what? 2. So that's 2 squared plus 8 times, in place of n, we put what? 2. So that was going to give us a 12 if we simplify. All right. Another way to verify that S1 is equal to T1. In this question of ours, we could have Also substituted in place of n, you put 1, so it's minus 1 squared plus 8 times 1. This was still going to give us what? A 7. So that is it. With these two, we can have the difference. That's T2. S2, 12. Minus S1, 7. So that's T2 is going to give us what? A 5. Why are we determining T2? Remember, we need to determine what? The constant difference. So this is for you guys who do not want to use what? That formula of Sn. This is another way that you could opt for. Now that you've got this, you can substitute. T5 is what? T2 is what? Is 5. Minus T1, remember T1 is 7. So that's our D is -2, our constant difference. With that, Tn can be determined as we have got our Tn as A, the first term, 7, plus n minus 1 times D, and our D is what? -2. So simplifying this, you are going to obtain what? Your Tn. So that's it. That's another way. 7, -2 times n, -2n, -2 times -1, +2. Then collecting our like terms, that's -2n, and we've got 7 and what? And 2. 7 plus 2, which is what? +9. So this is it. Same Tn that we obtained from that formula of Sn minus Sn minus. Same. But it is up to you guys. That is another way. Now that you've got Tn, you go back and solve as before. Remember, the question here is to solve for n if our Tn is -169. So therefore, minus 2n plus 9 is equal to -169. Solve just like before. If we were to solve this, our n was going to give us the same answer. We are back to the same equation. We are back to the same solving part. So questions, you see, so many ways of answering them. When you're given a question, it's exam. The way that you understand better, apply it. So that was question 2, 12 marks. Moving on to question number 3, we are given 3.1, given that k is equal to this summation where there is an infinity. All right? Determine the value, or okay, here they actually say the values of x. The values of what? Of x. For which k converges. Remember, when we are dealing with the sum to infinity, that's a condition where the series what? Converges. R must be greater than 1, but less than 1. So in our case, we already know it's what? It's a geometric. So for our R to converge, it must be greater than -1, but less than 1, which we do not have, as R must be taken from the terms T of n over T of n minus 1, meaning to say we can use T2 over T1. We can use that. For n is equal to 1, T1 is equal to what? We're going to substitute. That is what we given, 1 in place of n. So this is x minus 1 to the power of what? 1. N is 1. So guys, it's just going to remain as what? X minus 1, like that. Or you can put the power of 1, it's up to you. Then T2, it simply means it was going to be x minus 1 squared. All right, so guys, this is direct. T2, that's x minus 1 squared over T1. which is x minus 1 to the power of 1. Same um, basis division, simply subtract the exponents. So 2 minus 1 is going to give us 1. So that's x minus 1 to the power of 1, which is simply is what? X minus 1. So that's our R there. If R is x minus 1, we can solve for x as it is greater than -1 but less than 1. That is why they say the values of x, okay? It's because we're going to have an inequality there. So solving this inequality, what can we do is to get rid of the -1 on x. So simply add 1 each and every part of your inequality. We're going to add 1. So that is, this is going to cancel. So x is greater than what? -1 plus 1, that's a 0. But less than what? 1 plus 1, which is 2. So those are the solutions which represents the x. X can be taken from in within this interval as long it is bigger than 0, but less than what? But less than 2. The series converges, or K converges. Then calculate the value of K if x is 2 over 3. K represents what? The sum to infinity. K is the sum to infinity as this series what? Converges. 2 over 3. R is in within that interval, so we're dealing with what? A sum to infinity there. So that is it. We can answer this question 3.12. So as K represents the sum to infinity, what is the formula? A over what? 1 minus R. So that is it. So K is equal to A as the first term. We are given that as what? X minus 1. So A is what? T1. Remember? So that's x minus 1, where x is what? 2 over 3. So you're going to have 2 over 3 minus 1. So therefore, A was going to give us -1 over 3 from our calculator. 2 over 3 minus 1. Okay? So that's -1 over 3. And our R is also there in terms of x. So simplify it as we are going to need that one, x minus 1. All right, so these two guys, they're just the same. So R is x minus 1. T1 was x minus 1. So meaning to say it is the same minus a third. All right, so R and A, in our case, they are simply the same. Do not worry about that. It can happen. Just substitute as it is. So A is what? Minus a third. So we're going to substitute minus a third. Everything over what? 1 minus what is our R? Minus a third minus 1 over 3. So that was going to give us the value of K, the sum to infinity. So that's -1 over 3. You can even put a bracket in the numerator, or you can just leave it as it is, minus, open a bracket, minus a third, -1 over what? Over 3. So this is it. You're going to obtain -1 over 4 as the sum to infinity. Just like that. So you must pay attention to the question. Pay attention. You are working with the sum to infinity. That is why you see they did not even ask you to calculate the sum to first 10 terms or what. For x is equal to what? 2/3. Substituting that 2/3, our R is minus a third, which is what? Which converges. So in that case, sum to infinity. We can play around with that. What are the conditions? Converging part. So for any value of x in within that interval, 2/3 in that interval, so it converges. Sum to infinity. They will not even tell you about the number of terms there, because they know what you are dealing with. So this is it. Just make sure you go through questions, understand the question. We are given in this case, all right, do we have a diagram or something, or you must have it? All right, this is the diagram here. No problem. An air traffic control tower with 11 horizontal supports, 11 of them. 11 horizontal supports, like horizontally 1, 2, 3, 4, 5, 6, and so on. So here, it simply means there are so many horizontal supports which were not indicated. But as we are going like that, to say 1, 2, 3, going up to the last one, which will be what? Which will be equal to 11. There are 11 horizontal supports. Is constructed at an airport. The front view of the tower is shown in the diagram below, which is the one that we are having here. The length of the bottom horizontal support, 70 centimeters long. So it is the length of the horizontal support. So each horizontal line, in actual sense, each horizontal line is representing a support like this horizontal line. That's where it is starting, like that. Each horizontal line is a support. It's what? A support going up to the last one. Those are the supports. So they said the bottom is 70 centimeters long, the one that we see on the bottom here. It is what? 70 centimeters long. Okay? Then, and is secure to the ground. Each additional support is shorter than the one below it. Meaning to say, as we go up, the supports, they are reducing in terms of the size. As we are going up, the supports are reducing in terms of what? The size. From the previous one. It will be what? Reducing from the previous one. This is the condition of our question. So that the length of each horizontal support decreases with constant difference from each other. Meaning to say, guys, from each here, there's a constant difference throughout. Here, if it is 70, it's going to reduce by a certain difference. Maybe it's 2, maybe it's 3, whatever that it is going to reduce. It will be 70 minus that. It is reducing. So if it is a constant difference of D, it will be 70 minus D. As it is going to this one, it will be 70 minus what? It will be from this one, it will be 70 minus D. Then we reduce it by what? A constant difference of D. So at the end, you'll be having 70 minus D is what? Minus 2D. The same, this one, it reduces by what? By D. 70 minus 2D from where it is, it reduces by D. So minus 2D minus D is going to give us what? Minus 3D. So that's 70 minus 3D. So it is going to do, it is going to reduce like that, like that, like that, like that, like that. Constant difference throughout up to the last one. All right. So we're not told about that difference, but they said here, if the top horizontal support is 50 centimeters, if the top, last one at the end there, when n is 11, remember we're starting from 1 going up to the top, there are 11 of them. It is what? It is 50 centimeters at the top. The last one is 50 centimeters. Meaning to say, we do not know how many of them gave us to that, but it is the last one. We just know n is 11 there, all right? So I'm going to talk about that one. Do not worry. So they are saying which That is a question now. Which horizontal support has a length of 58 centimeters? Meaning to say find n there. It is just like find n given that Tn is equal to 58. That is the type of a question that you're given there. Find n if Tn is equal to what? 58. So how can you answer this question? Remember, there's a constant difference as we are given from a statement. A constant difference, meaning to say we are dealing with an arithmetic here sequence. So Tn, how do you find Tn under an arithmetic? Because we're dealing with an arithmetic. For an arithmetic sequence, Tn is taken as what? All right, so this one we talked about this. Tn is taken as a plus n minus 1 times d. So we can find that Tn and use it now to solve for what? To solve for this, where they are saying that which horizontal support, because Tn is what? 58. We can solve for n. But the problem, we do not have that. All right, so let's figure out what is it that we have. We have got A. Remember, we're starting from the bottom. It was instructed from the bottom. Going up, they are decreasing as they are going up. So the bottom is our first one. When n, for n is equal to 1, it means T1 is 7. So A, we have it because A represents T1. Remember that. So we have got A. In our case, A is equal to what? To 70 centimeters. We started with 70 centimeters at the bottom, representing T1. So A is 70. Then we are limited in our case. Remember, we want to find n, so we can work with anyone, guys, to find d, because we do not have d. Which one can we use? These ones, they are limited because we do not have equivalent of this. But what we know, it is the last one. The last one, it is when n is what? When n is 11. So if we try to figure out in terms of the approach of answering our question, we are simply saying that according to the presentation of our terms, this n is 11, Tn is a plus n minus 1 times what? Times d, where Tn is 50. So 50 is equal to a is not going to change. A is 70, we are starting at 70, plus n minus 1 times d. All right, sorry, n is there, n is 11, the last one. We want to find d, remember? So use the last one, times d, like this. The last one is there. N is 11. Remember, I told 11 what? Horizontal supports. So at the end, n is 11. So we can find the constant difference, as we are told this is what? An arithmetic. All right. So this to the other side, subtract 70. 50 minus 70 is negative 20. And that's 11 minus 1 is 10. So that's 10d. Divide by 10 to get rid of that 10 here. So our d is negative 2. So there is a constant difference of what? Negative 2. There's a constant difference of negative 2. So what does it mean? It simply means Tn here is equal to what? Tn, all right, sorry for that. We now have our Tn here. Tn is equal to A, which is 70, plus n minus 1 times d, where our d is what? Where our d is negative 2. Remember, our d is negative 2. So we can simplify it, I mean, here, or you can just substitute that Tn, which is 58. Then solve for n, or you can simplify this one before. Tn is going to be what? 70. Negative 2 times n is negative 2n. Negative 2 times negative is going to be what? Positive 2. So Tn is going to be what? Negative 2n. 70 plus 2, that's what? 72. All right, so this is our Tn for that arithmetic. And it's the same thing which is equal to what? To 58. So numerically, we can work with what? Numerically, we can solve for n numerically. All right? We can solve for x. For n, guys, where am I getting x now? Where am I getting the x? Solve for n. As these two, they represent the same thing. Minus 2n plus 72 is equal to 58. So that's it. Negative 2n. Get rid of the 72. Subtract that one, both sides of our equation. So we're going to have 58 minus 72, which is what? Negative 14. Negative 14 divided by negative 2 by negative 2. So our n was going to give us what? A positive 7 at the end. So n is equal to 7. So meaning to say it is T7. Because here they're asking which one it is equal to what? 58. So it is T7, which is equal to what? To 58. The seventh horizontal support is 58 centimeters. The seventh horizontal, as we are going up, 1, 2, 3, 4, 5, 6, 7. The seventh one, its length was going to be 58 centimeters. That is what it means. So this type of a question, you can actually answer it the way that you understand, all right? So many ways of attempting this type of a question. But that is what we had. That is what we had, guys, all right? So that is n is what? N is equal to 7 from what we are given. 5 marks, all right? Let's consider another part, which is question 4. Thus, we are on our functions. So given or to consider this function, write down the equations of what asymptotes, as we have got a hyperbola. Remember the hyperbola concept. If we are given f of x equal to x minus p plus q, the equations of the asymptotes will be taken from p and what? Q. X is equal to p, y is equal to q. So in our case, x is equal to what? From the x minus 1, we can get the value of x. So x is equal to positive 1. And as for the y is equal to what? Negative 1. As it is, y is equal to q as it is. But check, x changes. It was negative, now a positive. So x changes. Then 4.2, calculate the intercepts with the axis, meaning to say the x-intercept and the y-intercept, all right? So the first one was on the asymptotes. All right, so intercepts, let us consider the x-intercept. X-intercept first. Remember, y is equal to 0 for the x-intercept. When y is equal to 0, this is equal to 0, you solve for x, all right? So just take the right-hand side as it is. 0 is equal to the right-hand side as it is minus 2 over x minus 1 minus 1. Okay, so to solve for x, it is up to you guys because we are saying this is our equation. So what we can simply do is to take the one, it's up to you guys. You can take this one, becomes a positive. You can take this one, it becomes a positive. It was up to you. So as for me, I'm just going to get rid of one, add that one both sides. So that is 0 plus 1. 1 is equal to minus 2 over x minus 1. So we can cross multiply here. 1 is going to multiply x minus 1. So that's x minus 1. 1 times negative 2, negative 2. Simply add 1 both sides to get rid of that 1. So that is x is equal to negative 1. So meaning to say, as part of our x-intercept, we've got what? Negative 1, where y is equal to what? To 0. All right, then the y-intercept, do the same thing. That is, for the y-intercept, x is equal to what? To 0 this time. So from our f of x, in place of x, put a 0 there. So it was going to be y is equal to minus 2 over, in place of x, you put a 0. So that's it. You can simplify this on your calculator exactly as it is, minus 2 over what? 0 minus 1. Then subtract 1 as it is. That's a positive 1. All right. So therefore, the y-intercept where x is equal to what? To 0. Y is what? Y is equal to 1. So we've got our y-intercept from there. All right, on the diagram sheet provided, draw the graph. Do we have that? Okay, this is it here. All right, so that's our origin, the x, the y as it is. So the x values, it is 1, 2, but on the y is 2, 4, 6. Okay, no problem. Remember, we are dealing with what? A hyperbola here. So what we are going to need to understand is that from those asymptotes, what is going to be the shape? A is negative, less than 0. That affects the shape. We are going to have this on the other side, like the second and the fourth quadrant, but I'm referring to the asymptotes. When these are the asymptotes, this will be our shape. If it was positive, this side and this side. So meaning to say, this is what we need. Let's start with asymptotes first, then the shape will come. Asymptotes, x is what? 1. X is 1. This is our x is 1. So we're going to just have an asymptote there. All right, let's just have a broken line. Okay, x is what? Is 1. Going up like that. At the x value, direct at the x. X is what? X is equal to 1. Then the y is what? Negative 1. So negative 1, that is in between 0 and negative 2. Let's say this is negative 1. So you're going to have a horizontal line drawn as our asymptote there, negative 1, in between 0 and what? In between 0 and minus 2. It must be taken in between, right? Let's redo it. Let's redo it like this. Okay, so this is it. X is what? Negative 1 from what we are given here. I mean, y is negative 1. So we have got the x is 1, y is negative 1 as our asymptotes. Then if we are to consider there are intercepts, x-intercept at negative 1. So on the x values, x-intercept negative 1. All right, so the y-intercept is also given positive 1. So y is supposed to be at positive 1. This is 0, 2. So 1 is in between. Let us just say this is where we've got our 1 in between. So that is y and x. So according to the shape, as we can see, guys, remember I said this side and this side. We can see that on this side, there's nothing that you're going to have because of the asymptotes. We cannot reach the x-axis, we cannot reach the y-axis. So therefore, there is no x-intercept or y-intercept this side, right? So that is just going to be a shape of how it was going to look like, okay? But here, there are points, x-intercept, y-intercept. So join those, having the shape. So this will be our hyperbola, just tending to approach that, but it won't reach then to 1 here. All right, it's supposed to be exactly at 1. Or let me be from this side. Like this. All right. So this is it. Something like this. All right. Then on the other side, we just gonna draw the shape, just indicate the shape. You can have points if you want. Any point, maybe when x is 2, as you have got this part in place of x, we can just put a 2 like this. You can see that 2 and what? 2 and minus 3 is part of the points. And also maybe you can put a 4. All right, a 4. Yeah, let's just see. But that one is not necessary. Just leave it. It's not even necessary. Just 1 point. In fact, if they don't mention about having another point on the graph, then don't worry about it. But you can just indicate as you are used to this graph. So it's 2 and what? -3. So that's it. This is our whole function representing what? F. This is f of x. All right, the graph of what? The graph of f. So you can indicate your f anyway on these two graphs that we have. So it is a shape that side and another one that side. A piece, another piece and another piece separate because of what? The asymptotes. They separate these two graphs. It's a single graph, yes, but it's separate to say there's another piece there. There's another piece there. All right, so that is how it can be it can be like that in exam. Then another question was on 4.4, determine the equation of the axis of what? Symmetry of F, the axis of symmetry of F with a negative gradient. With a negative gradient. Remember, for the axis of symmetry, guys, there are just two forms. Y is equal to x plus c. Y is equal to what? Minus x plus c. So which one has got a negative gradient? The minus x. Minus x. So that one, we don't even need to be on the graph. No. We don't even need to be on the graph. Because we do understand that when you're dealing with the axis of symmetry, it can be this way, it can be like this. So the one with the negative gradient will be this one, which passes through the intersection of the asymptotes, where x is 1 and y is what? -1. This line crosses or passes through that point of intersection of what? Of the asymptotes here. So meaning to say, this is the one that we want with a negative gradient. So you can take advantage of where it passes through. Since we know its format, the one that has got a negative gradient, y is equal to minus x plus c, always like that. So substituting the point where it passes on the asymptotes, there is x and y value. Y is -1, where x is what? A +1. So we can solve for c. That is going to be -1, and this is -1. To the other side is going to be +1, -1 plus 1, which is what? Which is a 0. So c is equal to 0. Therefore, y is equal to what? Minus x plus 0. But our c is 0, so there's nothing to add. Just going to leave it like that. So that is the equation of what? Asymptote. The equation of the axis of symmetry, which has got a negative gradient. It passes through the intersection of what? simpletons. So you're going to take advantage of that and simply work out direct as it is. All right, so they play around with you. They try to play around with you guys. Just have to be very careful when attempting your questions. How to attempt, you must be very, very careful. So as we move on to question number 5, we are given that sketched below are graphs of what? F of x, which is given as ax squared plus bx plus c. That's a quadratic or a parabola that we are having. Then we have g of x, which is minus 3x plus 20. That's a linear. This is x to the power of 1. So we have got a linear there, which is a straight line. So those are the two graphs as of the sketch that we are given here. Our f of x and also the g of x, right? So let me just try to indicate them so that we can use them properly to answer our questions. So you can work with the PDF. It can be clear that way. As for me, guys, I just separate it so that we can properly see what is happening here. So this is it. Our f of x, then the g of x, which is our linear, the straight line. Those are the two graphs that we have. All right, the x-axis and y given. Then they told us about a, which is given as what? A turning point. 3 versus k. So we have given the value of x. We do not know the value of y. And as you can see, a is also a point, which is a point of intersection of the two graphs. It is a turning point. Yes, it's very true, but it is also a point of intersection. All right. Then the graph G, F, and G intersect at A and B as we are given at A and also at B. So that is what you're given. Make sure that you understand before you attempt the questions. 5.1, calculate now the numerical value of what? Of K. The Y coordinate of A. So K is the Y coordinate, which is very true. How can we calculate it? All right, so we cannot use f of x since on f of x there is nothing at all unknown throughout. But we can use the gx since a is a point of intersection. It is also found on what? On gx. So a, we can take advantage that it lies on what? A lies on what? On gx. Remember, if a point lies on a graph, you can use one coordinate to find the other one. So we've got the x coordinate. Use the x coordinate to find the y value as you are given gx. It means y is equal to minus 3x plus what? Plus 20. So use the x value, which is 3, to find the y value as we have got this part of our x, which is 3. So we are going to determine the value of y, which represents what? K. So y there represents k. So y is equal to what? Minus 3 times our x, which is 3, plus what? Plus 20. So you are going to simplify this, all right? You can even use your calculator. Minus 3, open bracket, put 3, then plus 20. All right, plus 20, like this. So it was going to give us what? 11. So that is the y coordinate, which means we've got what? The k. The value of k is what? 11. 5.2, determine the range of y is equal to minus, take note, minus f of x. So first we have got this graph of f of x. Remember, at the turning point, that's where we can have our range. At the point of a, which is 311, we are limited to the y value to say at what? At 11, going down. So in that case, y is less than or equal to 11 for what? For f of x. That will be our range. But in our case, they are not asking for f of x. No, they are asking for y is equal to minus f of x. All right. So for y is equal to minus f of x, it simply means, one, this is a reflection that happens in the x-axis. A reflection that happens in the x-axis, meaning to say this was our f of x. When we reflect it in the x-axis, it will be like this. This will be its reflection. So as we had the turning point where y is equal to 11, this time it will be reflected to y is equal to minus 11. Remember, the reflection, you move same distance to the mirror line, it is the same distance going down. So meaning to say y is equal to minus 11. That is the y value at the turning point where the x value, remember, as you reflect across the x-axis, the x value is not affected. So the point was going to be 3 minus 11 as your turning point. But you are worried about the y value. Y is what? Minus 11. So therefore, as the range, this graph is limited from minus 11 going up. So we're talking about the values that are greater than or equal to minus 11. So therefore, our range was going to be y is greater than what? Minus 11. Values greater than minus 11 or minus 11 up to what? Up to infinite. That will be the condition of our y values. All right. So you must take note, guys. Be very careful about the question. All right. Y is equal to what? Minus f of x. 5.3, calculate the numerical values of A, B, and C. A, B, and C, we saw these from our f of x. A, B, and C from our f of x. That is, we've got A, B, and C. So we can work it from what? From f of x. All right, so that's 5.3. We must calculate the value of A, the value of B, and what? C. All right, so like I said, working from f of x, let's see what we can do, because that is where we do not have these values. That is where we have got these A, B, and C, and we need the numerical values now from this. Okay, if we understand that f of x, which represents our parabola or the quadratic function, there are so many ways of obtaining this function. So many ways. If I was given the x-intercepts, we're simply going to use y is equal to a into x minus x1 into x minus x2, as x1 and x2 represents the intercepts, but we do not have intercepts. We do not have those values. So we are limited to this expansion, which was going to simply expand it to this form. But what is it that we have given what? From f of x, we are given the turning point and the point B, which is any point that we have. So there's a point which is a special point, the turning point, and what? And any point, and any given point. Remember the condition. When you are given a turning point and any point on the graph of a parabola, you can determine its equation from the turning point. Remember, from the turning point, y is equal to a into x minus p squared plus what? Plus q, where pq is our turning point. So take note, it will be negative. In our case, our turning point is the point A, which is the point 3, 11. Remember, the value of k is 11. We calculated it. So if you were going to take this, you're going to have y is equal to a into x minus p, which is the x value there, which is what? Which is 3 squared, plus the q, that is the y value as it is, which is 11. So there is a missing part, which is a, which we can determine from that any point which lies on what? On our f of x. Remember, b lies on f. That is our any point, which is the point b. Using the point b, which is 6 versus 2, where I've got x value and y value, we are going to use it to determine or to find what? To find a. All right. So substituting the y value that we are given from the point B, the y value is what? Is 2. So that's 2. All right. So we're going to have this one. 2 is equal to a. We need to find the value of a in that case. Into x, our x is what? 6. So the 6 minus 3 squared, as it is here, 6 in place of x. So we just substituted what represents y as 2, our x as what? As 6 from the point B, using the point B. All right, so that's plus 11. So we can simplify this, okay, for us to solve for what? For us to solve for a. That is how you can play around. So you see, it can be easier that way. All right, solving for a, we can take or just subtract 11. All right, so this was going to cancel. 2 minus 11, that is negative 9, is equal to 6 minus 3 squared. That was going to be 3 squared, which is 9. So that's 9 times a, which is 9a. All right, you can just use your calculator. 6 minus 3, then you square it. All right, so divide by 9 by 9, that is going to give us the value of a. So a is equal to what? Negative 1. So remember here, it is to find the values of a, these values a, b, and c. So we just have the value of a. To find b and c, we can simply substitute back into this. All right, let me indicate the step. We can substitute back here. Remember, we have substituted here our a, so let us just focus with this one. Substituting our a, it means y is equal to, in place of a, we've got what? Negative 1. So it was supposed to be negative 1 into this, so you can just put negative as it is like that, all right? X minus 3 squared plus 11. The question is not for you to give an equation. It is for you to find A, B, and C. So it is easier for us to find or to determine A, B, and C if we are to expand our equation or this part that we are given into this form. All right, so y is equal to, let us expand. All right, remember guys, I talked about this a minus b concept. A minus b squared equal to a squared minus 2ab plus what? B squared. So it was going to give us the negative, that's going to be a, which is x squared, minus 2 times 3, which is 6x, plus 3 squared, that is 9. All right, plus 11. So expanding with the negative, each term, negative times x squared minus x squared, negative times negative, that is going to give us a positive. All right, negative times positive, that's a negative. All right, then add 11. 11 is not affected by this negative. It is only affecting the bracket. So meaning to say at the end, y is equal to minus x squared. As we simplify our like terms, we have got minus 9 and what? Minus 9 and 11. So minus 9 plus 11, that's a positive 2. So this is a positive 2. Okay, so this is it. This is what you're given. So as you have got this format similar to what you're given, it'll be easier, but that's your f of x, this one. So it is same as what you're given there. Y is equal to what? Ax squared plus bx plus c. From there, it is easier for you to tell what exactly represents your a, the coefficient of x squared, which is what? -1. The same a that you obtained there. The same a that you obtained there, as you can see. So therefore, a is -1. B, the coefficient of x. So b is equal to what? +6. C, the constant, and our constant is what? Our constant is 2. From the format of the given equation, from that format, you can use it. You can play around that format that you are given to determine these values. All right. So that is how these questions can be given as. Use what you are given, the turning point and any given point. From there, you can determine the equation of what? Of the parabola in terms of what? The turning point form. But expand it so that you have what? That other format. And there you can see, all right, this is my A, this is my B, and this is my C. All right, determine the values of what? The value or values of x for which f of x is greater than, it is bigger than what? Gx. F of x is greater than, guys, remember I told you for this type of a question, you need where the two functions are to be compared at their intersection, where the function is bigger than the other one. It means where the one is on top of the other. So f of x to be bigger than gx, as we are given on 5.4, for f of x to be greater than gx, f of x is supposed to be on top of gx. F of x is supposed to be on top of what? On top of gx. Where is it that we have our f of x on top? If we compare at point A and point B, all right, from point A going to the left side, we can see that G is more positive. It is the one that is on top, whereas F is below. So this one is totally wrong, this section. From 3, the value of x, there is 3. Here is what? Is 6. From 3 to 6, in between this intersection, right? In between this intersection, we can see that f is on top. This is our f on top of what? Of gx. Gx is below. This is exactly what we want. It must be on top. It must be positive compared, more positive compared to this one, on top. So we need that part, 3 to 6. We move on the last end for values that are greater than 6. G is now on top. Look at F. F is now below. So we do not want this. So the only part that satisfies our condition is between 3 and what? 6. So X is greater than 3, but less than 6. In between. In between. Our question, we do not have equal to. So we cannot put that equal to on our answer. We leave it. If there was an equal to, then you must put that. But in our case, we do not have. So we leave that part as it is. All right. So you see, guys, easy like that. 12 marks on question number 5. Everything that we are given there. All right. Anyways, let us consider another part of our question, which is question number 6. They gave us hx. Given hx, a to the exponent of x, and a is greater than 0. And a is not equal to 0. It must be bigger than 0, not equal to. Then there's a point B given, is a point that lies on H. The point B. The graph HX. All right. So it lies on H. Then the graph HX is a point on the graph. All right. Then there's another point. All right. This one, it was just another statement which was not necessary. They just wanted us to have this one. It lies this one. the point B only. All right. Anyways, 6.1, it was determine the value of A. So to determine the value of A, guys, we can just use our hx as it is. All right. Because there we've got a point B that we are given. All right. We can use that y is equal to what? A to the exponent of x. All right. So we can, so meaning to say, we can just substitute this our x and y value. So 1 over 2 is equal to a to the exponent of what? Negative 1. Our x value is negative 1 there. So we need to find or to calculate the value of a, remember? So to get rid of this negative, it is on the exponent, remember? So its reciprocal, when it is negative 1, it is still a negative 1, okay? 1 over minus 1 still gives us what? Minus 1. So we're going to multiply by minus 1. We're going to raise this to the exponent of negative 1. So exponent to exponent. That is going to give us a positive 1. A to the exponent of 1, which is what? Which is A. But 1 over 2 to the exponent of negative 1 is going to give us what? A 2, which you can use your calculator. 1 over what? Over 2. Everything raised to the exponent of negative 1 like this. So that was going to give a 2. All right, so that's our A. A is equal to 2. Let us consider another part of the question. Write down the equation of what? The inverse of h in terms of y is equal to, right? The inverse. Remember, hx is, a is 2, so that's 2 to the exponent of x, all right? So let us see if y is equal to 2 to the exponent of x, the inverse, remember the steps, we must interchange x and y. So that's x is equal to 2 to the exponent of y. Then we make y the subject. All right, we make y the subject. So those are the two steps. So how can we make y the subject? Remember the conversion of the logarithmic form, the log of a in the base of b to be equal to c. It means a is equal to b to the exponent of c. So that is it. We can also convert from this exponent form to the log form as y is the exponent, just like c. It means once we convert to log form, c is the subject, of which this is what we want, for us to have c as the subject, which is y there. So therefore, it is the log of what? Of a, which is our a is what? Is x. In the base of b, our b is 2, which must give us what? C, of which our c is y. So that's it. This is our inverse. Y is equal to log x base 2. So as they said, in the form of y is equal to, so it's going to be y is equal to what? The logarithm of x in base of 2. So that is the inverse of what? Of our h. Then they're saying here, sketch the graphs. All right, sketch the graphs of h and its inverse on the same set of axes. All right, clearly show all intercepts with what? With the axis. All right, so let's check. Okay, we're given the graph that was provided was this part, which we used previously. So let us see what we can do. All right, this is h of x is an exponential function. Remember, h of x is an exponential function, which when we are dealing with h of x, the x-axis is our asymptote. All right, so our x-axis is the major case, which is our asymptote at that moment. So meaning to say, our x-axis, we're going to have it as an asymptote, and it is going to be increasing in terms of the values. And as we have got x-axis as the asymptote, it means we don't have x-intercept. We have the y-intercept, where x is equal to 0, y is equal to 2 to the exponent of 0, which is 1. So the y-intercept is the one that we have. The y-intercept, which is at what? At 1. So it crosses the y-axis at what? At 1. And x-axis is our asymptote. So meaning to say we're going to have our graph or function going up like this. All right. And it's going to be just somehow limited because this one like going to have something like here 2 to the exponent of 2, 4 to the exponent of 2. All right. Something like that. So it was just going to be something like this. Okay. All right. This one is too much. All right. Let me just remove this one, my asymptote, so that I can just focus on the major part of the graph. So guys, you see, working with the software is not easy. It's just smooth. It's just a smooth graph. All right. This thing of wanting it to be smooth, even though the software, you see, guys, it affects us. But anyways, this is it. Something like this. The x-axis as your asymptote, and the special point will be 0, 1, which is your y-intercept. Another point, you can use 0.24. Remember, a to the is 2 to the exponent of x. When x is 2, 2 to the exponent of 2 is what? It's 4. So it can be any other point. And when you are drawing hx with its inverse, because this is the inverse, remember this is due to the reflection and the line of what? Y is equal to x. The line y is equal to x is the one that reflects the original to its inverse, and y is equal to x is just a condition. When we say x is minus 2, y is also minus 2. If x is 2, y is also 2. If x is 0, y is also 0. So it was reflected in that line of y is equal to what? Y is equal to x, which is an important aspect for you to just remember to say it's a reflection. So whatever that we are going to have, it simply indicates that reflection in the line of y is equal to x. All right, so let's consider the reflection. The reflection will be on the other side. So even if you do not know the graph that you are working with, you can simply reflect the points along the line of y is equal to x. Remember, you just swap the points. This point, if it is 0, 1, we're going to have it as what? As 1, 0. We swap it. If there is a 2 versus 4, we swap them. So it's going to be 4 versus 2. It's a point. So meaning to say we're going to have a logarithmic function which is affected by that. All right? That is according to the conditions that we are having. What is it that you are given as the x value? All right? What is it that you have as your x values? So we are talking about a logarithmic. All right? So, all right, let us consider. Guys, I was talking about this one coming here. All right? This one coming here. Okay. 2 versus 4. We're going to have it as 4 versus minus 2. So if you consider the shape now, all right, if we check, this is what, let me also consider this as we are together, guys, so that you understand me as well. As you, all right, sorry for that. You understand me very soon. I need that equation. Yeah, all right. It is log of x base what? Base 2. Also, in terms of a log, you must know that the asymptote is the y-axis. So it is limited, just like what we were given. For that, it was the x-axis. And remember, you're interchanging everything. So it will be the y-axis for the what? For the log. So it is limited. So it's going to be in that manner. And we need, all right, uh, guys, I was talking about the point 4 versus 2, not 4 minus 2. This is 2, 4. 4 versus 2 here. All right. Sorry for that. This is another point that we need. 4 versus 2. And this one. And the y-axis is our asymptote, the y-axis. So the graph cannot reach the y-axis. It's going to be something like this. We've got 2 points, the x-intercept, and any other point, which is that a reflection of in the line y is equal to x. If this is 2, 4, this will be what? 4, 2. All right, so that is it. There we have got our inverse, which is the log graph, or just understand, guys, the graph of a log. All right. If you understand your graphs, then there's no need for all this. What is the domain now of the inverse? Write down the domain of what? The inverse of h. So the domain, remember, those are the x values. How is it limited? We are talking about what? A logarithmic. The y-axis is our asymptote. So that's for x is equal to 0. Our graph is limited to values greater than that. X is supposed to be what? Greater than 0. We cannot have values that are less than. So x is greater than 0. That is what we're going to have as part of our domain. So each and every part, we must be very, very careful. Each and every part that we are given. All right. If we consider another part, if we are to consider now, they need us to write down the value of values. There are two things there. Value of values on 6.5. Of, for which, it was just all right, for which the inverse of h is greater than what? Greater than 1. The inverse is our logarithmic. This is the inverse. Where is it that is greater than 1? This is y is equal to 1. Remember, y is equal to 1 here as part of our y-intercept. We know that y is 1. So this is the line. Y is equal to what? To 1. So the question here is asking you to say that what are the values of x that the inverse is greater than? The inverse is bigger than what? 1. This is our inverse. So with the line of y is equal to 1, where it is greater than, it must be above that line. And this is the intersection where y is equal to 1. What is the x value as you will be going up? So we need the value of x there. What is the value of x? All right. What is the value of x as it is going up? So here, guys, do not worry about my graph. It can be just by coincidence that our x can be at 2. It means if it is like that, it means I have drawn this graph in a better manner. All right. Anyways, we need the value of x. So don't take it as 2 because this is a sketch, guys. But if it is like that, then it means we are correct. So let's find the value of x. Remember, hx is what? The inverse is a log. So let's solve for x because we just need that critical value. Log of x in base 2. We are not saying is equal. We are not saying is greater than 1. We are saying is equal to 1 because we need what? Critical values. So in this case, it is just a critical value that we're going to have. Only one value of x. So remember, converting from log to exponential, x is equal to 2 to the power of 1. So x is equal to 2. This is our critical value, which is exactly this one that we have here, where it meets with the line of y is equal to 1. That's at x is equal to 2. It was just by coincidence to draw a smooth graph which tallies like that one. Anyways, we need values that are above that line. above y is equal to 1, above on top. That is, the inverse is supposed to be above. And this starts at this point here where x equates to what? To 2 as our critical value as we solved. So it means x must be greater than what? Must be greater than 2. We're talking about values bigger than 2. Values such as 3, 4, and so on. For those values, the inverse of h will be what? Will be greater than 1. It will be on top of the line y is equal to 1. That is what it means. All right. So that is for which values? So therefore, x is greater than what? Greater than 2. As we compare it from the graph, our value is going this side. They are greater than what? They are greater than 2. All right. So this is it. We are done. If it is given that tx is equal to this, describe the transformation from h to t. All right, from h to t, 6.61. All right, so let's have the two graphs. 6.61, h of x originally is what? 2 to the exponent of x. Remember, a is 2, so that's 2 to the exponent of what? Of x. This is our hx being transformed to tx, and tx is given as 1 over 2 to the exponent of x minus 1. So first, let us try to have a format similar to this. 1 over 2 is same as 2 to the exponent of negative 1. So that will be to the exponent of x. So negative 1 times x. That means we're going to have 2 to the exponent of minus x. Minus 1 times x, exponent to exponent. Then minus 1. All right, now that we have got a format similar to that, all right, this is 6.61. Now that we have got a format similar to this one that we are given before, we can tell what happened from our hx, which was to the exponent of x, but now it is minus x. What happened? It was x. Now it's minus x. Are you seeing this is f of minus x? It's a transformation, this one, that we must know. F of minus x. It was a positive, but look, it changed to minus. It means in place of x, we substituted minus x. So what does f of minus x mean? A reflection in the what? In the y-axis. Remember, there's the x and what? The y-axis. A reflection in the y-axis, where x values changes from this point to another point. If it is positive 2, it will be minus 2. So that's the minus x concept. So we are talking about a reflection in the y-axis. That's the first transformation. So we have got a reflection in the y-axis. The y-axis in the y-axis. All right, but that's not all, because when it reflected, here it was like a 0. There was a 0 originally, but here look, there's a minus 1 here. What does it mean? From 0 here, now it is at negative 1. It means it's a shift going downwards. 1 unit going downward, all right? So that is, and a shift of what? A shift of 1 unit downwards. It affects the y values. So it is just direct as it is 1 unit down or downwards. So that is it. You compare when it is in the same format, you can see what exactly are the effects. Those effects are the transformations that you must describe. A transformation is just an effect to say how is the graph affected from its originality. How was it affected? Just like that. So 13 marks. 13 marks that you're going to have on question number 6. Revise as many questions. All right. No, there's another one that we left. There is another one. which is this one. Determine the equation of the asymptote of what? T. The equation of the asymptote. Remember, this is our Tx. So the equation of the asymptote is the -1, which is the y value. Y is equal to -1. So that's 6.62. All right. So you get 18 marks. All right. Just like that. Question number 7, which is the part of our trigonometry. We are given that the sine of 35 degrees is equal to k. All right, determine in terms of what? In terms of k, given that the sine of 35 degrees is equal to k. This is k over 1. So from our soccer tour concept, we are having what? Opposite over hypotenuse. Opposite to 35, this is the hypotenuse. So determine the third side from your Pythagoras theorem. That is going to be the x part that is remaining here. X squared is going to be hypotenuse squared, 1 squared, minus k squared. So that's 1 minus k squared under the square root to have our x. 1 minus k squared under the square root. All right. So yeah, just quickly simplified our Pythagoras as we are now used to it. And also determine the remaining angle. You might not know what you need from that. So these two angles, they are complementary. Remember, they add up to 90 degrees. So simply subtract from 90 minus 35, which is what? 55 degrees. Just like that. So as we have got this, the first question, it was cos 55, and we have that 55. It was an advantage, this one, as the cos of 55 degrees is just supposed to be taken from adjacent over hypotenuse. According to 55 degrees, this is our adjacent, right? So it's k over 1, which is what? Which is k. All right. The sine of 70 degrees, the sine, we do not have 70 from there. All right, but let's see. 7.12, 70, but there's something about 35 and 70. 35 times 2, it's 70. So it is the same as what? Sine 70 is the same as sine 2 times what? 2 times 35. Why having 2 times? Remember the double angle concept. For a sine, we can have, or we can use the double angle concept that is given as what? The sine of 2 alpha, alpha as the angle that you're given is 2 sine alpha cos alpha. So meaning to say, if it is 2 times 15, this will be 15, this will be 15. If it is 20, this will be 20, this will be 20, this will be 20. So in our case, it is what? 35. So if this is 35, this will be 35, this will be what? 35. So this is what we simply need. All right. So let us use that one. So this was going to be 2 sine 35 degrees times cos. It's sine cos 35 degrees. Double angle identity has been used. We have sine 35, cos 35 can be determined from the diagram according to 35 degrees. This is our adjacent, remember? So adjacent over hypotenuse, all right? So that's it. Let us simplify. So that was going to be 2 times sine of 35, which is k originally given. All right, we have this one times the cos of 35. Remember, adjacent over hypotenuse. Our adjacent, square root of what? 1 minus k squared over hypotenuse, which is 1. So that was going to give us what? 2 times k, that's 2k, square root of what? 1 minus k squared. All right. So this is cos what? Cos, this is sine of 70 degrees in what? In terms of what? In terms of k. Play around with the information that you're given. Try to make sense out of it. Do we have anything, an identity that can be formed? 7.13, the cos of 80 degrees. Cos 80. All right, 80 degrees is not that easy to have because we do not have 40 degrees. So we cannot talk about a double angle. Also, it is an acute angle. It is already a reduced value. It's reduced. So there's no way we can think of reducing it again. But we can think of is that 80 from special angles. If it is like that, when it is complicated, think of special angles as well. Because from special angles, we know the answers. 45 degrees, we have 30 degrees, 60 degrees. Is there any part out of these that we can use as a combination? Adding or subtracting together with these ones that we have originally from our diagram, which is 35 degrees and what? 55 degrees. Because these ones, we have them in terms of K. In terms of what? In terms of K. So we can take advantage of that. Is there any part when you combine, you obtain 80? So you're going to see that it is happening between these two angles, 45 and what? 35. If we add 45 plus 35, this is 80 degrees. So you can take advantage of that one and say this is equal to cos 45 plus 35. Just like that. 45 degrees is a special angle. 35 degrees is not a special angle, but we have it on our diagram in terms of K. So that can work properly. Going back to our identities, cos alpha plus beta. What do we expect when it is cos of alpha plus beta? Cos alpha, cos beta. So it's cos, cos, sine, sine. And the sign changes to a minus. So it was going to give us cos, this is alpha, this is beta. So it's cos 45, cos 35. The sign changes, minus sine, sine, sine 45, sine what? 35. Just like that. So we've got everything, guys, because these are part of what? Our special angles. So cos 45, sine 45, we know them. Even if we do not know them, we can just use our calculator direct, or you can use our special angles. The cos of 45 is what? Square root of 2 over 2. Or you can use 1 over square root of 2. It's up to you. All right. Cos 35 from the diagram. Remember, we talked about this adjacent over hypotenuse. So that gave us square root of what? Square root of 1 minus k squared over 1, which is just like that. Minus the sine of 45 degrees. Originally, we have it. Sorry. We do not have that one originally, but we have the sine 35. The sine of 45 from our special angles, which is same as cos 45. Remember, sine and cos are the same. But the sine 35 is the one that we are given originally here. Sine 35, which is what? Which is k. So we can use that k. So we have substituted each. We are done. If you want, you can factor out the square root of 2 over 2, this one, which is common. Square root of 2 over 2. Factoring out, you're going to remain with what? The square root of 1 minus k squared. Minus, here we're going to remain with what? With k. So our answer is in terms of k. Just like that. They repeat these questions Now and again. It's a repetition. 7.2, if the sine of x minus cos x is equal to 3 over 4, then calculate the value of sine 2x without using a calculator. How can we calculate sine 2x given cos x? All right. Sine 2x. Remember from sine 2 alpha, it is the same as 2 sine of x cos of x. This is sine 2x. So where can we get 2 sine x cos x from this statement? Where can we get that? That is what you can think of. Where can you get sine 2x, which is this part, this term, 2 sine x cos x. If I have sine x and cos x, this can only happen when we square the bracket. Remember, a minus b squared, like this. It is a squared minus 2ab plus b squared. So to have this 2ab, this one, the 2 sine x cos x, 2ab, it means we must square it. So let's try to square it. Sine of x minus the cos of x is equal to 3 over 4. If we square the left-hand side, we must also square the right-hand side. Remember, it's an equation. Whatever that you do on the left-hand side can be done also on the right-hand side. So by squaring these, you're going to have sine squared, a squared. So that's sine squared x minus 2ab. So it was going to be 2ab sine x cos x plus what? B squared, which is the last term squared, cos squared. So that's cos squared x. And that's equal to 3 over 4 squared, which is what? 9 over 16. So I want you to notice something that is important here. We have what we need. 2 sine x cos x. 2 sine x cos this one. We simply need to replace it with what? Sine 2x. Sine 2x, remember, is what you want. So you're done. That part will be represented by what? Sine 2x. So it means we are having sine squared of x minus the whole part here, 2 sine x cos x, represents sine 2x. All right? Then we can focus with other things. But exactly what we want is here. Sine 2x. This is exactly what we want. So what we're going to simply do is to make it the subject of the formula. But how can we make it the subject? Because there is still a sine squared and a cos squared. Do not worry about these two. Remember, sine squared plus cos squared gives us what? A 1. Plus cos squared of x is equal to 1. So meaning say these combined, it's 1. Minus what? Sine 2x equal to 9 over 16. Remember, your major objective is to find sine 2x. So taking the 1 to the other side, that's simply subtract. All right? So you're going to have minus sine 2x, as this is going to cancel, is equal to what? 9 over 16 minus 1 is going to give us a negative 7 over 16. So to find sine 2x, you divide by what? Negative. There is your sine 2x. As a numerical value, sine of 2x is equal to what? 7 over 16. As a numerical value. They play around with you guys. So revision is very, very important. Revision is very, very important. Understand the examiner, the mind of the examiner. Understand it. All right. So anyways, that was it. We have got sine 2x as a numerical value. That was our question. Okay. Let us consider another part. It was simplify to a single trigonometric ratio. All right. Here it's very easy. As you know, as you know, all trigonometric properties as I explained. All right. So that's 7.3. Let us just answer it direct, or can I just write equal to here because it's direct here? All right. The tan of 180 plus x, remember that's a positive angle, 180 plus x in the third quadrant. This is 180 minus x, this is x, this is 360 degrees minus x. Those are positive angles. So 180 plus x is in the third quadrant. So using the cast concept, that's for tan. So tan is positive there, tan of x, reduce it. 360 minus x is a positive angle. 360 minus x in the fourth quadrant, the quadrant for cos, and that's a cos, so it's going to remain as a positive as it is. X minus 180 is no longer a positive angle. X minus it, we do not have that on positive angles. It's a negative angle. Remember, for negative angles, this is where we're going to have our minus x. Then you're going to have x minus 180, minus 180, or minus x minus 180 in that one. And this will be x minus 360. These are negative angles. So x minus 180 lies in the third quadrant, which is the quadrant for tan from our cast concept. It is for tan. But we are talking about what? A sine. So sine will be what? Negative there. So that's negative sine of x. Reduce it. Cos 90 plus x, all right, this is from our core function concept, which lies in the second quadrant. So cos is negative, so it's going to change to a negative sine of x. All right, so these two are under a product, just open bracket for these two. Then there's a plus here to separate them. So plus, we separate them. All right, cos 270 plus plus sorry, 720 plus x. So 720 is more than 360. So subtract 360. That is going to be 360 plus x. We can also subtract 360. That is going to be 0 plus x, which is x. So that is cos x. All right. So that one is equal to cos x. They're just completed revolutions back to cos of x. Cos minus x is a negative angle. Minus x is a negative angle. Where cos is what? Positive. So it's going to be positive cos. In the fourth quadrant, cos is what? Positive. All right. So that's it. Tan can be written as what? Sine over cos. Do not forget sine over cos times the cos of x. Everything over what? Negative times negative, that's positive. So it's going to be sine squared of x plus cos times cos, cos squared. Remember, guys, I talked about this, our Pythagorean identity, which gives us a 1. Sine squared plus cos squared is equal to 1. So that was it. This was going to cancel in the numerator because it is the same as cos x over what? It is same as cos x over 1. So this can cancel. You remain with what? Sine of x in the what? In the whole numerator. Then in the denominator, this is 1. So it is just sine of x at the end. As a single trigonometric ratio, it was going to give us the sine x. So you see, they will ask you these questions. Just try to play around, understand the question. All right. So it was for 6 marks. Then 7.4, prove that the left hand side is equal to the right hand side. All right. Let me take the left hand side, most complicated, a lot of things there. So 7.4, we've got cos 2x. All right, cos 2x. So let me just work out left-hand side, which is equal to cos 2x plus cos squared of x plus 3 sine squared of x, everything over 2 minus 2 sine squared of x. Okay, what can we do? The answer is a cos only. It is just a cos only, cos squared. Just a cos. There's no sine there. So we can get rid of the sine, every sine that is there, since the answer is cos. All right, cos 2x. Remember, cos 2 alpha, 3 identities. Since our answer only has a cos, just take the one that has a cos, or you can take anyone, guys, but this is the best. Cos 2, 2 cos squared alpha minus 1. This one is the best that we can use. All right, since it only has a cos. We just need a cos. So that's 2 cos squared x minus 1. Already here is a cos, so just leave as it is. All right, the sine squared. Remember, sine squared from our Pythagorean. Sine squared of x is equal to 1 minus what? Cos squared. When we took the cos squared. So whenever we see it, we can replace with this one. So it's going to be plus 3 into sine squared 1 minus cos squared of x. Then our denominator as well, we can simply change that sine squared to be written as a cos. Remember our answer, guys, there's only cos there. We do not have sine. So it's best that you just get rid of all the sine that is given. All right, so let's simplify the numerator. 2 cos squared x minus 1 plus cos squared of x. 3 times 1, that is positive 3 if we expand the bracket. 3 times minus cos squared is minus 3 cos squared of x, everything over 2. We expand the brackets, negative 2 times 1, which is negative 2. Negative 2 and negative here is going to be positive 2 cos squared of x. All right, the numerator, we've got like terms, so simplifying those like terms, this is cos squared, cos squared. So 2 plus 1, that is 3, minus 3, this was going to cancel. So the cos squared cancels. Then we are left with the numbers minus 1 plus 3, which is what? 2. Over what? These ones cancel 2 minus 2. So we are left with what? 2 cos squared of x. 2 and 2, the numerator concept. So that's 1 over the numerator denominator concept. I mean, you can cancel those. That is, we have got the right-hand side as it is exactly our right-hand side. This is shows that we have proven our identity. Then determine the general solution of this 2 sine x cos, all right? It has nothing to do with this one. We never had something like that. 2 sine x cos x. This is, we never had. So this one is a question on its own. We're not going to take it from 7.4. We're just going to work it separately as it is. All right, let's see, guys, how can we solve this? All right, 2 sine of x cos x minus cos squared of x is equal to 0. Remember, we need what? The general solution. So the general solution can only happen if we have got a single trig, sine of x equal to a, or it can be cos of x equal to a, or it can be tan of x equal to a. That is where we can have general solutions. So when it's like this, it is complicated until we can separate that. All right, so what can we do? All right, if we check, there is a cos squared. There is a cos here. Cos is common. You can factor out cos of x. So meaning to say it's going to be 2 sine x minus, there are 2 of them. So you're going to remain with 1 cos of x because there are 2. Cos squared means there are 2. The cos times cos, like you're multiplying cos times cos. So you're going to remain with cos x equal to 0. The 0 concept, a times b to be equal to 0, it means a is equal to 0 or b is equal to 0. So it's either cos of x is equal to 0 or the bracket of 2 sine of x minus cos x is equal to 0. So that's it. There we have got a single trig, which is exactly what I want here, to have a single trig, cos x equal to a. So this one is fine. We can find our general solution from there. But here we do not have a single trig. There's a sine, a cos. All right, let's try to produce or have a tan from there. If we take cos to the other side, it's going to be positive 2 sine x is equal to cos of x. How can we have a tan? Tan is the same as the sine over cos. So to obtain this, simply divide by what? By cos. By cos. So this can cancel. So sine over cos, this is what we want. Sine over cos, which is what? Which is tan. So it was going to give us 2 tan x. 2 tan of x equal to what? To 1. So thus we can have tan x if we divide by what? By 2. So tan of x is equal to 1 over 2. This is exactly what we want, to have this condition. It must be a single trig. From there, determine your general solution. All right, so from the first one, our reference angle is going to be simply arc cos of what? Arc cos of 0, which is what? 90 degrees. So we can have this condition where cos is equal to 0, the 90 degrees. 0 cannot be positive or negative. It's either. So for you to exactly know where we have got this cos, we can even check the graphical part of cos. It is like this. So 0 at 90 and 0 at 270 degrees. So meaning to say, therefore, x is equal to the reference angle, 90 degrees. Remember, for cos, it's reference angle plus k times 360. Another one is going to be cos, where it is positive, or we do not know now to say where is it positive, because 0 can be positive, can be negative. So you cannot consider that, but you can work with the graphical method, all right, to say it's at 90 and 270. So this is plus k times 360, or we can have our x being 270 degrees plus k times 360. This is what happens at 0 degrees. You must, when cos x is equal to 0, or when cos x is equal to 1, you must be very careful on those two. All right, so that is it. In this condition, our k must be an integer. All right, so that was the first set of our solutions from cos. From tan, we do the same thing, but this one, at least it's something that you can work out. The reference angle first. Arctan what? Arctan 1 over 2. Arctan 1 over 2, which is from your calculator. Shift tan, then 1 over 2. That was going to give us what? 26.57 to 2 decimal places. All right. Remember the instruction of the question paper that you're having, to 2 decimal places. So that's 26 comma 57 degrees as our reference angle. So tan, remember, where it is positive from our cast, it's going to be first, and that one which is 180 degrees minus reference angle. So therefore, our x is going to be equal to, in the first quadrant where tan is positive, start with that one. Where tan is positive in the first quadrant, you just take the reference angle as it is. So it's just reference angle plus what? K times 180. The period of a graph of a tan is what? 180. So our reference angle 26.57 plus K times 180. All right, or where tan is positive again in the third quadrant, 180 minus the reference angle 180 plus. Guys, in the third quadrant it's plus there. Sorry for that. 180 plus our reference angle 26.57. If you add, it was going to give us 206.57. All right, plus K times 180. So that's it, and still our k is being what? An integer. So those are the solutions that you're going to have, this set and also that other set. So it was going to be two of them, two sets. From the cos, we have got this. From the tan, we have got this. So you combine it. So that is it. These questions can be given like this. You just have to revise as many questions as you can, try to figure out. This is revision, guys. As you can see, 100 marks for this question that we just did. All right, let us revise, guys, as much as we can. Where we do not understand, as part of membership, let us communicate. All right, do not communicate last minute, guys. Let's revise before. Find time to have revision. All right, before you now start to rush around. Now it's exam time. You are rushing. Prepare now in as much as you can. So let us do that. We are going to see that our marks, they are going to improve, or our grades, they are going to improve. All right. So that is it, guys. Till we meet again.